Okay, let's dive into this. When you picture Saturn, you probably imagine this serene, timeless gas giant that's basically looked exactly the same since the dawn of our solar system, right? Well, welcome to this explainer because we are going to completely shatter that illusion. Today, we're investigating a cosmic whodunit. We're going to pull apart some incredible recent scientific discoveries to reveal the violently chaotic and surprisingly recent origins of Saturn's beautiful rings. Here's a totally mind-bending fact to kick things off. Saturn itself formed right alongside the rest of the solar system, making the planet roughly 4.6 billion years old. But those iconic rings? Current data suggests they are, at most, 100 million years old. I mean, just let that sink in for a second. That means dinosaurs were already roaming the Earth for a solid 150 million years before Saturn even got its rings. This staggering age gap is the central cosmic anomaly we're untangling today.
Now, it's not like this is a new puzzle. We've actually been trying to figure out these structures for centuries. Back in 1610, Galileo became the first person to point a telescope at Saturn, and he was completely baffled. He actually described the rings as handles or arms on the planet. It took almost 50 years of optical improvements before Christian Huygens correctly deduced it was a ring in 1659. And then shortly after that, in 1675, Jean-Dominique Cassini discovered a major gap in the structure. But despite hundreds of years of non-stop observation, the true violent history of these rings basically remained entirely hidden from us until very recently.
And this brilliantly illustrates our first major modern clue in this cosmic crime scene, which actually comes from the Cassini spacecraft. After hanging out in orbit around Saturn for over a decade, its instruments revealed that the rings aren't just some random mix of space rocks. They're actually composed of 99.8% pure water ice. That incredible, pristine purity is exactly what makes the rings so blindingly bright and highly reflective, even when we're just looking at them through telescopes way back here on Earth. Now, what's really interesting about this slide is the sheer scale of the rings, or actually, the total lack of it. Cassini helped scientists effectively weigh the rings, clocking their total mass in at around 16 quadrillion tons. I know, 16 quadrillion sounds absolutely massive, right? But in astronomical terms, it's virtually nothing. To put it into perspective, it's actually less than 0.02% of the mass of our own moon. Which brings us to a literal scientific bombshell. Low mass plus bright ice equals young rings. Here's why this is such a massive revelation. Space is really dusty. Over billions of years, constant impacts from wandering space dust and micrometeorites act a lot like pollution. If Saturn's rings were old, this relatively tiny amount of ice would have been heavily polluted and darkened a long, long time ago. The simple fact that they are still so bright and pure proves, without a doubt, that they must have formed very recently.
So, how does a solid moon actually turn into a dusty ring? To understand that, we have to talk about a physics principle called the Roche limit. Basically, this is the minimum safe distance, usually about 2.5 times the planet's radius from its center. Think of it as a gravitational danger zone. For Saturn, that boundary sits at exactly 87,000 kilometers. If a moon crosses that invisible line, the planet's gravitational tidal forces become so incredibly extreme that they easily overpower the gravity holding the moon together. Anything solid that strays inside that limit gets literally ripped apart and shredded.
Which brings us to the obvious question. What exactly got shredded? Well, a groundbreaking February 2026 study from the SETI Institute, led by astrophysicist Matija Čuk, finally identified the prime suspect. And get this, the culprit behind all this destruction wasn't some rogue comet or an outside invader, it was an inside job. The finger points directly at Saturn's very own and very massive largest moon, Titan. When the SETI team ran these incredibly extensive computer simulations of the ancient Saturnian system, looking at the complex gravitational dance of the planet and its moons, they found a really alarming pattern. In 42 out of 60 simulation runs, they got the exact same catastrophic result, a massive collision. Their models revealed that about 400 million years ago, an early version of Titan violently crashed into another ancient massive moon that they've dubbed Proto-Hyperion. Let's move to the next step and see how this builds. Because this wasn't just a random fender bender, it was a devastating chain reaction. It all started when Saturn slipped out of its spin-orbit resonance with the other planets. Just that tiny gravitational shift was enough to push Proto-Hyperion into a deadly 2-to-1 resonance with Proto-Titan. Basically, for every one orbit Titan made, Proto-Hyperion made 2. This created a rhythmic gravitational tug-of-war that aggressively yanked Proto-Hyperion inward, inevitably leading to their paths crossing, and then, all hell broke loose as the two massive proto-moons collided. This crash fundamentally transformed Titan forever. Pre-collision Titan was smaller and comfortably sat in a nice circular orbit. But the modern Titan we see today essentially received a massive geological facelift. Huge portions of the moon were resurfaced during the merger, smoothing over old craters and giving it this unexpectedly youthful appearance. But even more dramatically, the sheer force of the impact knocked Titan into a highly elliptical orbit. So today, it's basically fleeing the scene of the crime, drifting outward from Saturn at a surprisingly fast rate of 11 centimeters every single year.
So the crucial point is how Titan's expanding orbit sets up the final act of this tragedy. Fast forward to about 100 million years ago. As Titan continued its rapid outward drift, its massive gravity swept through the system and caught two smaller inner moons, locking them into a deadly 4-to-1 resonance. This shifting relationship warped their orbits until they inevitably smashed into each other. The incredible force of this secondary crash pushed the shattered icy debris straight across that deadly Roche limit we discussed earlier. Saturn's immense gravity did the rest, shredding the fragments and spreading that pure water ice out into the dazzling, thin disk of rings we see today.
You know, what makes this explainer so exciting is that Matyachuk's model doesn't just tell us where the rings came from, it acts as a complete master key for the whole system. This one elegant, interconnected model solves multiple bizarre mysteries in one fell swoop. It explains Saturn's weird 27-degree axial tilt, which happened when Titan's expanding orbit violently messed with Saturn's rotational wobble. It explains the tumbling, highly irregular shape of the modern moon Hyperion, which is quite literally just the loosely bound, leftover shrapnel from that first massive collision. It explains Titan's rapid outward drift and even why the distant moon Iapetus has such a highly tilted orbit. The whole shebang perfectly connects into one grand, violent story.
Of course, it's a brilliant theoretical model, but science demands hard proof, right? Well, we might just get it very soon. NASA's upcoming Dragonfly mission is officially scheduled to launch in 2028. This thing is incredible. It's a nuclear-powered, car-sized rotorcraft that will actually fly through Titan's thick atmosphere and land right on its surface. When it arrives in late 2034, it's going to be specifically searching for the chemical and geological evidence of that massive historical resurfacing. Dragonfly could absolutely be the final puzzle piece that proves this entire violent history to be a fact.
But before we wrap up our investigation today, we do have to pivot to a slightly melancholy realization. During its final daring dives through the inner rings, the Cassini spacecraft revealed that Saturn's rings are, sadly, actively dying. Right now, individual icy particles are constantly jostling each other, causing a steady rain of ice to fall out of orbit and directly into Saturn's atmosphere at a staggering rate of up to 40 tons every single second. Because they are constantly bleeding material like this, these majestic rings might only last for another few 100 million years.
Which leaves us with a final, pretty provocative question. What will Saturn look like in another 100 million years? Honestly, it's highly likely that this dynamic gas giant will go right back to being completely ringless, looking exactly as it did when the dinosaurs first walked the Earth. It really makes you stop and realize just how incredibly lucky we are to exist in this specific, fleeting moment in the cosmos, arriving right on time to witness the aftermath of Titan's destruction and to enjoy Saturn's beautiful but very temporary masterpiece.